Okay, last lesson what we learned is using the derivative graph to find the original graph. And we can use derivative function to find the original function. Let's have a look at an easy question here. Example 8. Okay, I already write answers on it. So find the equation of the curve by dy defined by dy dx equals to e to the power of 2x, given that the curve passes through 0, 5. So I can integral e to the power of 2x to have the original function, but I need to plus a constant at the back. I don't know how large is this constant, therefore I need another point to help me to work out the c value. So the curve passes through 0, 5, which means when x equals to 0, y equals to 5. I sub that in, 5 equals to a half e to the power of 0 plus c, which c gives me 9 over 2. And the original equation should be y equals to half e to the power of 2x plus 9 over 2. And example 9, similarly, example 9, a population is increasing according to the law P. According to the law dp dt equals to 100 e to the power of negative 0.1 t. Okay, I need to find, like, A tells us, given that there were 500 koalas initially. Okay, this 500 koalas, which is the same as the previous question, 0, 5. Okay, that tells us when t equals to 0, p should be 500. And I want to find expression for p in terms of t. P should be integral of 100 e to the power of negative 0.1 t dt. Then p is 100 divided by negative 0.1 e to the power of negative 0.1 t plus c. Okay, so that is my equation, but I don't know the c value. So I need to find the c value, sub 0, 500. So 500 equals to negative 1000 e to the power of 0, which is 1, plus c. So c is 1500. So p is negative 1000 e to the power of negative 0.1 t plus 1500. That is A. And let's have a look at B. Sketch the graph of p versus t for the first 10 years. Okay, obviously this is a exponential graph. Okay, what I need to be aware of is, okay, for the first 10 years, I need to be aware of the domain. Okay, let's just sketch. So I have asymptotes here. Asymptotes is 1500. So I need to sketch that here. So that's the asymptotes. Make sure it's p equals to 1500. And I have my initial value. Initial value is 0, 500. So I will have a point here. Okay. This graph, okay, over base E. So the graph looks like that, and it needs to reflect twice because the negative here and the negative here. So reflect by y looks like that, and reflect by x it looks like that. So it's an increasing graph below the asymptotes. So I should have a graph like that. Okay, approaching to that. But I need to stop at 10 years because it asked me to sketch for the first 10 years. So this point is 0, 500. This point will be 10, comma. I need to sub 10 into the equation. So when t equals to 10, p equals to negative 1000 e to the power of, okay, negative 1 plus 1500. Okay, so I will have 10 comma negative 1,000 over e plus 1,500. Okay, that's the exact value. That's for part B. Okay, for C, find the exact time when p equals to 900. Okay, exact time, so you can't use calculator. So when p equals to 900, 900 equals to negative 1,000 e to the power of negative 0.1 t plus that. Okay, I can move this term to the left hand side, so 1,000 e to the power of negative 0.5 t equals to 600. E to the power of negative 0.1 t equals to, okay, 600 divided by 1,000 is 6 over 10, 3 over 5. Okay, I can write here. So negative 0.1, 0.1 is 1 over 10. T equals to log e, 3 over 5. T equals to negative 10 log e, 3 over 5. Or I can say that's 10 log e, 5 over 3. Okay, that's the time. The unit is years. Okay, that's years. That's this question here. And have a look at the next one. Next one is really important. It's more like a VCA type question. So for this graph, the graph of the function h is shown below. And I want to find the original graph. Okay, I want to find the original graph. This is a derivative function. I want to find the antiderivative graph. So I need to use the table. So to set up the table, I have x value, and say that's h as I can say that's h dash x, or h let's say the dy dx, and then that's the graph. Okay, I need first empty, second one I have the point 0 here, empty next one, the next one I should have a, and here. Okay, those 2 points have 0 and 0. And to the left of 0, I have all negative values. All negative values. In between 0 to a, I have positive values. To the left of a, I have negative values. So I have negative, 0, positive, 0, and negative. So at a, I have two turning points. Okay, at A is a maximum turning point, and at 0 is a minimum turning point. So this one doesn't work because at 0, this is and A, they don't have turning point. Okay, let's have a look at C. A, I have maximum, but here is a minimum, so it can't be that one. Okay, for this one, although crack here, but I have another turning point which is not really works, so I don't have that one. And for this one, I only have one turning point that doesn't work, so the only one left is A. Okay, the only one left is A. So that's this multiple choice question here. Okay, for example 10, the position of a particle x meters from the point O at time t seconds is given by xt graph. Okay, we have three types of graph. We have xt graph, we have vt graph, and we have at graph. Okay, from here to here is differentiation. From here to here is differentiation. Okay, if you go backwards is antidiff. Here to here is antidiff. Okay, VT graph is the most helpful one. Okay, remember VT graph is the most helpful one. Even though I know if give me XT graph, I can find VT graph. But most of the time, we will use VT graph to help us to calculate the question. Okay, let's have a look at the question below here. The initial position of the particle. So the initial position, I would say x0. Okay, the initial position is when t equals to 0. So I want to find x0. So x0 is negative 15. I can say the particle is 15 meters away to the negative direction of the origin. Okay, you should understand that negative direction doesn't really mean negative direction. The direction is what I defined as positive. Well, if I define left-hand side as positive, then left-hand side can be a positive 15, not negative 15. So when I see a negative 15, it must mean it's a negative direction of the origin. Okay, next one. The position of the particle after 6 seconds. Okay, after 6 seconds. So I want to find x6. 2 times 36 minus 42 minus 15. That's a 72 minus 57. That is a 15 meters. Okay, you can say the particle is 15 meters away to the positive direction of the origin. Now we can think about what is the this change in displacement. Okay, what's the change in displacement in the 6 seconds? So initially the particle is let's just say negative direction is the left. Okay, negative direction is the left. So that's the origin. That's negative 15. That is positive 15. This is the particle when at 0 seconds. Well, this is after 6 seconds. Well, I don't really know what happens in between, so it can go for like that. But in the end, it will stop at 6 seconds at 50 meters away. So the displacement is 30. Okay, this displacement is 30 in 6 seconds. Okay, the next question is asking, well, let's skip the first, those two, C and D first. Let's have a look at E. E is asking what is the average velocity over the first 6 seconds. Okay, average velocity is very important. You need to remember the formula. Average velocity equals to change in displacement over time taken. Okay, it asks you over the first 6 seconds. Okay, the first 6 seconds, initially the particle is at negative 15. And it travels, I don't know how it travels, but in the end, it reached the point 15 meters away to the right. Okay, so from 0 to 6, the displacement is a positive 30 because the particle has moved to the right for 30 units. So it takes 6 seconds in total. So the average velocity will be calculated as 15 minus negative 15. That's the final position. Subtract the initial position. That equals to final position. Subtract initial position. Okay, so that is over 6. 30 over 30 over 6, 5 meters per second. Okay, 5 meters per second. Okay, let's go back here. This is asking you what is the distance traveled by the particle. Okay, we have like, I know 2 ways to find distance, but the best way I want you to know is looking at distance and displacement by using velocity graph. So I can find my Vt equals to 4t minus 7. Okay, let's sketch this graph. Okay, let's sketch this graph, 4t minus 7. So we have, should draw it this way. This is Vt graph. You can find xy intercept. So I have that. Okay, this is my Vt graph. Okay, this is my Vt graph. I just extend this a little bit longer. What I'm interested in is the first 6 seconds. Okay, 6 is here. Okay, if I can go beyond here a little bit. Well, the scale is not very good. Let's just suppose here is 6. Okay, let's suppose here is 6. Okay, this is 4t minus 7. Oh, wrong way. Sorry, just sketch it wrong way. I need to go up. Okay, just sketch here and okay, on I have -7 here. Okay, and I have this point here. Okay, this is the graph. Okay, this is the graph. And the point 6 is here. Okay, intersects here. This point is 7/4, comma 0. This is 0, -7. And this point is 6, comma, okay, 4 times 6 is 24. 24 minus 7 is 17. Okay. Now this is a VT graph. As we talked about before, we know the area can be total area or signed area on a graph. Okay, so if I use this area to subtract this one, that will be the signed area. If I use this area plus this area, then that will become the total area. So on the VT graph, the area under the curve can be written as if is displacement that is the same as to talk about the signed area. If it talk about the distance, that's the same as talking about total area. Okay, let's find what is this area. Okay, what is this area? This area gives you, that's 7/4, that's a length of 7. So it's a half times 7/4 times 7. That is 49/8. Okay, and let's have a think about this area. 6 is 24/4. So is 24/4, that's 7/4. Here will be 17/4. So it's a half times 17/4 times 17. So 17 times 17, 289. Okay, 289. That's 289/8. Okay, let's just check our displacement, because you know that from 0 seconds to 6 seconds, the displacement is 30. So let's just check that. If I use the top to subtract the bottom, okay, 289/8 subtract 49/8, that gives me 240/8, that is a 30. That is the displacement. Okay, displacement can be found by this method as well. Well, if I want to know the distance, I need to add them. Okay, I need to add them. So distance traveled by the first 6 seconds, I will use 289/8 plus 49/8. That's 338/8. That is 169/4. Okay, 169/4. Next question is asking what is the average speed. Average speed. Okay, it's asking the speed without the sign. Okay, over the first 6 seconds. That will equals to the total distance over the time taken. Okay, all total distance over the time taken. So that equals to 169/4 divided by 6. So times 1/6. That equals to divided by 3, which is 2. Divided by 3 is can't divide by 3. Okay, can't divide by 3. So that gives me, can't divide by 2, can't divide by 3, so it's 169/24 meters per second. That is the average speed. Okay, average speed is always positive because your distance is always positive. But the average velocity can be positive or negative or like 0. So it's really compares to where is the final point compared to the original starting point. Okay, so that's how we find average velocity and average speed. This is very important. Okay, the particle's initial velocity, which is -7 meters per second, okay, which is this point here. It means the particle is traveling to the left, okay, at 7 meters per second. When and where the particle is instantaneously at rest. Okay, when and where instantaneous at rest. So that means Vt equals to 0. So 4t minus 7 equals to 0, t equals to 7/4. That is when. And if it's where, it's asking you the displacement. Okay, x 7/4. That equals to 2t squared, 2t squared minus 7 times t minus 15. Okay, that is 49 over 8 minus 49 over 4 minus, okay, let's say that denominator 8, 120. Okay, that is a minus 49 over 8 minus 120 over 8. That equals to negative 169 over 8 meters. Okay, at negative 169 over 8 meters, the particle is instantaneously at rest. Okay, last one asks you what the velocity of the particle as it passed through the origin. Okay, it passed through the origin. So let's have a look at what is our xt. 2t squared minus 7t minus 15. Okay, 2t squared minus 7t minus 15. I want that equals to 0 because this passes through the origin. Okay, 1, 2, 5, and 3. I need a negative 7. Negative 10 plus 3 is negative 7. So t minus 5, 2t plus 3 equals to 0, which t is 5 or t is negative 3 over 2. Okay, because t can only be greater or equals to 0, so t is 5. Ask you the velocity, so it's v5 equals to 4 times 5 minus 7 is 13 meters per second. It is traveling to the right by 13 meters per second and passes through the origin. Okay, is that 40 minus 7? Okay, 4 times 5 minus 7. Okay, this question is quite important. It's talking about like very important formula. Average speed, not this one. Average speed and average velocity. Okay, must remember those two formula, and you must learn how to use the VT graph to find the displacement and distance. Let's have a look at the next one. The next one is a very similar question. Okay, the first one, the velocity, I want to just change something first. I just want to change only to when the particle is stationary. Okay, the velocity of an object at any time. The velocity of an object v meters per second at any time is given by that equation. Find the displacement of the particle after 15 seconds. Okay, after 15 seconds, 0 to 15 seconds, I want to know the displacement. So if I want to know the displacement, I need to know the signed area. Okay, then the next question is asked about the distance. So what I need to know is the total area. So without sketching this graph, okay, for the first one, I need to, okay, that is the x. Okay, x equals to integral from 0 to 15. Okay, 3 pi cosine pi t over 4 dt. Okay, that is the signed area. Okay, just integral a graph normally, that gives you the signed area. So that's the displacement. Because it's a VT graph, integral VT graph, the area under the curve from 0 to 15 seconds, that will give you the displacement, which is the signed area. So that gives you 3 pi times 4 over pi. Okay. And cosine will become sine. Okay, still have pi t over 4. You want to have that, 0 to 15. X equals 2, that's a 12. 12 can be taken out. So inside is sine 15 over 4 pi minus sine 0. Okay, sine 0 is just 0. Sine 0 is just 0. So what is 15 over 4 pi? That is s minus 16 over 4 pi. So that's minus pi over 4. Okay, sine minus pi over 4 is here. Is minus sine pi over 4. That is minus root 2 over 2. Okay, minus root 2 over 2. So what I will do is x equals to 12 times minus root 2 over 2. That gives you minus 6 root 2. Okay, so in the first 15 seconds, the displacement is minus 6 root 2 meters. Okay, that's the first one. And for the next one, it's ask you the total distance. Okay, if it's a part 1 exam, you need to sketch the graph and to calculate part by part. But if it's a test question, what I can do is distance equals to integral from 0 to 15, absolute value 3 pi cosine pi t over 4 dt. Okay, I put that in the absolute sign and I can find the total area under the curve. So let's have our calculator open and calculate that. Okay, shift plus 0 to 15. Okay, 3 pi times cosine pi times must have this times if you use t here, pi t over 4 of dt. Okay, that's the signed area, and we need to know the total area. So if we want to know the total area, what I need to have is this absolute sign. Okay, let's drag the whole thing into the absolute sign. Let's have a look. Okay, this one is 6 times 16 is 96. Okay, 96. This gives us 96 minus 6 root 2 meters. So the distance traveled is that one. Okay, the distance traveled is that one. So if you need to go hand approach, you need to sketch the graph first and then find that part by part. Okay, above one, below one, and add all of them together. And see. When the particle is stationary in the first 20 seconds, okay, in the first 20 seconds, so Vt equals to 0. Okay, 3t cosine pi t over 4 equals to 0. Okay, I can just 3 pi go out. Cosine, what equals to 0? Cosine, okay, so that equals to cosine pi over 2 equals to 0, and 3 pi over 2 equals to 0. I can times 4 on everything. Pi t equals to 2 pi and 6 pi. And divide by pi is 2 and 6. So what is the period? The period equals to 2 pi divided by pi over 4 is times 4 over pi. That equals to 8. So I can add 8. Okay, both of them can't subtract 8 because t can't be negative. I add 2 on 8 is 10. 6 add on 8 is 14. Okay, 8. 10 add 8 is 18. 14 add 8 is 22. So it says first 20 seconds, 22 is out of the domain. So you're at those 5 time instant, that particle will be stationary. Okay, 2, 6, 10, 14, and 18. Okay, 2 and 6 is the answer in the first period, 10 and 14 is the second period, 18 and 22 is the third period, but 22 is out of the domain. Okay, that's another motion question. Just quickly go through some of the next exercise. Okay, which is the last exercise? Okay, last point of knowledge, which is a really easy formula, but students keep forgetting that after we learn everything. We'll learn probability next term, and when you come back to this, you may forget it. Every year there will be some students asking me, oh, what is the average value? I haven't learned average value. I said, no, you definitely learn it in chapter 11, but you just can't remember it. So this exercise is asking you average value. So what is average value? You know, like in between, okay, for example, A to B, there will be, okay, some high point, some middle point, some low point, and high again. Okay, there are different y values. Okay, different y values. What I'm interested in is, what is the average height of it? Okay, what is the average height of it? So you can treat this question like, okay, now I have a graph here from A to B. I have area here. That area is 5. Okay, I want to know if I can give a uniform height from A to B, make a rectangle. So what height can make a same area compared to before? So say if I have height here, okay, I'll just go this way. Okay, this red area is 5 as well. Then this height will be the average value. Okay, this height will be the average value. So therefore, the formula will be integral from A to B. Okay, from point A to point B, integral this fx, which gives you the area. And then I would divide by the length. Okay, the length of this rectangle, B minus A, which is the length of this rectangle. This, after divide that will give me the width. Okay, that will give me the width, which is the average value. Okay, you can think about the definition as that. Okay, we have some area, blue area before. Now I want to make a rectangle to give the same area as the blue one. So what is the width I should have? Okay, that is the average value formula. So therefore, let's have a look at example 12. Let's have a look at example 12. So find the average value of the function given for the given interval. Okay, for this one, first 1 to 5. Oh, the area must be the signed area. This area is the signed area. Okay, 12, x squared, 1 to 5. Okay, x squared, 1 to 5. So integral 1 to 5 of x squared dx. That gives me the area under the curve. The width, the length is 4 from A to B. That is 4. So it's 1 over 5 minus 1. 1 over 5 minus 1. So this equals to a quarter times, okay, that is a third x cubed. 1 to 5. I can say that's 1/12. Put a third out. 15, 5 cubed. 25 times 5, 1 to 5 minus 1, which is 1 to 4. And that gives me 1 to 4 on 12. Okay, I can divide this by 3. Divide that by 3, by 4. Let's divide that by 4. That gives me 3. Divide that by 4 is a 31. So 31 over 3 is the average value for this graph from 1 to 5. Okay, B. Sine 2x, 0 to pi. So it's 1 over pi minus 0, integral 0 to pi, sine the area, sine 2x dx. Okay, that's 1 over pi. This is negative a half, cosine 2x, 0 to pi. Okay, sine back to cosine, that will be negative. Okay, that will be negative. So therefore, we have negative 1 over 2 pi cosine 2 pi minus cosine 0. Okay, cosine 2 pi and cosine 0, they're the same thing. Therefore, that's just a 0. So that equals to 0. The average value is 0. You may question why the area will be 0. So let's sketch sine 2x. That's sine 2x, that's pi. The period is pi now. So that's pi over 2, that's 0. You can note this blue area is the same as this red area. The area under the curve, the sine the area under the curve from 0 to pi of this graph is 0. So which means there's no area. Therefore, the width must be 0 as well. Okay, last one. I'll go through the last one today. Example 13. Find the average value of C such that f average equals to fc. For this function, the average between 0 to 3. So what is the average? Let's find the average first. So f average equals to 1 over 3 divided by 1 over b minus a, integral 0 to 3 x squared minus 4 dx. That is a third x cubed minus 4x 0 to 3. So that's a third. When you sub 3 in it, that's a 9 minus 12. When you sub 0, that's a 0 and 0. So basically that's a minus 1. Okay, that average value is a minus 1. Okay, so FC equals to negative 1. Okay, FC, that's negative 1. So FC equals to negative 1. So FC is c squared minus 4 equals to minus 1. So c squared equals to 3. C equals to plus minus root 3. Okay, c equals to plus minus root 3. So I will just stop here. You can have a think about all the things we have learned today, which is quite important, especially the last exercise here. This formula is very important. So make sure you get enough revise.